Hello everyone, how are you doing? I hope you all are fine. Today we are going to study H.C.F and the exercise related to it. I hope you would enjoy my video, so please stay with me till the end of this video. H.C.F. It is also called GCD. GCD, that is greatest common divisor. So what is H.C.F? Let's understand the concept of H.C.F by a small example. I'll take the two numbers 12 and 18. Let's write down the factors of 12 and 18. The factors of 12 are 1, 2, 3, 4, 6 and the number itself 12. The factors of 18 are 1, 2, 3, 6, 9 and the number itself 18. If we see here 1, the number 1, the number 2 and the number 6. The number 3 is also common between them. So the number 1, 2, 3 and 6. These four numbers are common between the numbers 12 and 18. And among these four common numbers, we can say that 6 is the highest common number between 12 and 18. So what is H.C.F? How do we define H.C.F? H.C.F is the greatest number that can divide the given numbers. Our given numbers are 12 and 18. And 6 is only the number. 6 is the only greatest number that can divide 12 as well as 18. You cannot find other number greater than 6 that can divide both 12 and 18. So H.C.F is the greatest common number that can divide the given numbers. Let's take an example of three numbers 21, 28 and 35. What are the factors of 21? 1, 3, 7 and the number itself 21. The factors of number 28 1, 2, 4, 7, 14 and the number itself 28. The factors of the number 35 1, 5, 7 and the number itself 35. So if we see here, we can see that the number 1 and the number 7, these two numbers are the common between these three numbers. And among these common numbers, we can see that 7 is only the greatest number, which is common between these three numbers. So 7 is the H.C.F of the number 21, 28 and 35. So from here also we can see that the greatest number, 7 is the greatest number that can divide 21, 28 and 35. So H.C.F is the greatest number that can divide the given number. So the greatest whole number, which is a common factor of two or more than two whole numbers, is known as the H.C.F of the given number. Methods of finding H.C.F. There are three methods of finding H.C.F. The first method is writing all the possible factors. In this method, we write down the factors of the given numbers, and among those factors, we shall select the common factors, and among those common factors, which is the greatest factor, that is the H.C.F of the given numbers. Let's take an example, 10 and 15. What are the factors of 10? 1, 2, 5 and 10. The factors of 15, 1, 3, 5 and 15. So what are the common factors? 1 and 5. And among these two common factors, the greatest common factor is 5. So our H.C.F is 5. Let's see one more example. 12, 18 and the number 20. The factors of 12, 1, 2, 3, 4, 6 and 12. The factors of 18, 1, 2, 3, 6, 9, and the number itself 18. The factors of 20, 1, 2, 4, 5, 10, and the number itself 20. So if we see here, we can see that the number 1, the number 2. Only these two numbers are common between these three numbers. So among these common numbers, the number 2 is highest. That is, the number 2 is highest common factors between the number 12, 18 and 20. So the number 2 is the H.C.F. Don't be confused here. You might see the number 3 common between 12 and 18. And you might think 3 can also be the H.C.F. But remember, H.C.F is the common factors between all the numbers given. That is, you cannot take the common number which is common between any two numbers. You should take the number which is common between all the numbers which are provided to us. The number 2 is factorization method. Or you can also say it as prime factorization method. So in this method, we shall write the number as the product of the prime factor, and we shall select the common factors between them. That is, the common prime factors between them, and we shall multiply, and we shall get the product at the H.C.F of the given numbers. Let's take an example. The number 12 and 18. We shall find out the H.C.F of 12 and 18 by prime factorization method. Now express 12 as the product of prime numbers. Factorize 12. 2 6 is 12, 2 3 is 6. So 12 can be written as 2 into 2 into 3. Now factorize 18. Let's see. 2 9 is 18, 3 3 is 9. So 18 can be written as 2 into 3 into 3. So H.C.F. As I told you, in prime factorization method, we shall select the common prime numbers and write down their product. So the common prime number is 2 into 3. That is, the common prime numbers are 2 and 3. So find the product of 2 and 3. It's 6. So 6 is the H.C.F of 12 and 18. So in this way, we shall find out the H.C.F by prime factorization method, or simply you can say factorization method. Let's take one more example. 24, 32 and 40. Find the prime factors of 24. 2 12 is 24, 2 6 is 12, 2 3 is 6. So 24 can be written as 2 into 2 into 2 into 3. Now factorize 32. Find the prime factors of 32. 2 16 is 32, 2 8 is 16, 2 4 is 8, 2 2 is 4. Remember that you can take only the prime numbers. You cannot take the composite numbers. So 32 can be written as 2 into 2 into 2 into 2 into 2. Now find the prime factors of 40. 2 20 is 40, 2 10 is 2 5 is 2 into 2 into 2 into 5. Now select the common prime factors. 2, 2 and again 2. So the H.C.F is 2, another common number 2, and again another common number 2. 2 into 2 into 2, 8. That is, 8 is the H.C.F of the numbers 24, 32 and 40. The third method is division method. In this method, the smaller number shall divide the greatest number, and the remainder again will divide the divisor. In this way, it will continue until the number which can divide, that is the number which will be able to divide the divisor, will be considered as the H.C.F of the given numbers. Let's understand by an example. I have taken two numbers, 12 and 30. The smaller number is 12. It will divide the greatest number 30. 12 1 is 12, 12 2 is 24. 6. Now the remainder 6 will divide the divisor. This 12 with the divisor here. So 6 will divide 12. 6 2 is 12. So 6 could divide the number. That is, at last 6 divided the number. That means 6 ended the game. So our H.C.F is 6. Let's take another example in the case of three numbers. The numbers 28, 35 and 42. The smaller number will divide the greater number. 28 1 is 28. 7. Now 7 will divide 28. 7 4 is 28. We saw that 7 is the H.C.F of 28 and 35. But we are not sure if 7 is the H.C.F of 42. Let's see. The H.C.F of 28 and 35, which we got here, shall divide the remaining number 42. 7 6 is 42. Now we can clearly say that 7 is the H.C.F of all these three numbers. Therefore, H.C.F is 7. Let's start the exercise. Exercise 3.2, creative section A. Question number 4. Let's write all the possible factors of these pairs of numbers, then find their H.C.F. Now from the given pairs of numbers, we have to write down all the possible factors. Let's write down. So the factors of 6, I shall write down as F6. It indicates factors of 6 equal to. So I have to write down them in curly brackets, since it indicates the set of factors of 6. And the elements of set are always written inside the curly bracket that we will learn in the chapter called set. Okay, factors of 6. 1, 2, 3, 6. Factors of 8. The factors of 8 are 1, 2, 4, 8. Now let's see what are the common factors. The common factors are 1 and 2. And among these common factors, 2 is the greatest common factor. Therefore, highest common factor, that is H.C.F is 2. This is our answer. Let's say in this question, factors of 12. What are the factors of 12? 1, 2, 3, 4, 6 and 12. The factors of 16, 1, 2, 4, 8 and 16. Let's see the common factors 1, 2 and 4. So among these common factors, the highest common factor is 4. Now the next question, the factors of 18 and 24. Let's find out. F18, that is the factors of 18. 1, 2, 3, 6, 9, 18. That is 1, 2, 3, 6, 9 and 18 can divide 18. So these are the factors of 18. The factors of 24. So what are the numbers that can divide 24? 1, 2, 3, 4, 6, 8 12 and 24. Now let's select the common factors. 1, 2, 3, 6. Okay. These are the common factors. And among these common factors, 6 is the greatest. That is our H.C.F is 6. 6 is the H.C.F of 18 and 24. Now let's come to this question. Factors of 27. 1, 3 can divide 27, 9 can divide 27, and 27 itself can divide 27. Factors of 36. 1 can divide 36, so 1 is the factor of 36. 2 can divide 36, 3 can divide 36, 4 can divide 36, 6 can divide 36. After that, 9 can divide 36, 12 can divide 36, 18 can divide 36, and the number itself can divide 36. Okay. Let's select the common numbers, common factors. 1, 3, 9. So 9 is the highest common factor. The next question. Factors of 30. What are the factors of 30? 1 can divide 30. 2 can divide 30. 3, 5, 6, 10, 15, and the number 30 itself can divide 30. So these are the factors of 30. Now the factors of 40. What are the factors of 40? 1, 2, 4, 5, okay, then 8, 10, 20, and lastly the number 40. Now from these numbers, what are the common numbers, common factors? Let's point out. 1, 2, 5, and 10. Among these common factors, we see that 10 is the highest common factor. So our H.C.F would be 10. Okay. The next question. Factors of 32. 1, 2 can divide 32. Then after that 4, 8, 16, then finally 32. Now factors of 40. As we had already written in previous question, you can take the help from there. 1, 2, 4, 5, 8, 10, 20, and 40. Now let's point out, that is, let's select the common factors. 1, 2, 4, 8. Okay, only these are the common factors. And among them, our H.C.F is 8. Since 8 is the highest common factors between 32 and 40. Question number G, 36 and 48. Let's find out the factors of 36. 1 can divide 36, 2 can divide 36, 3 can divide 36, 4 can divide 36, 6 can divide 36, 9 can divide 36, 12 can divide 36, 18 can divide 36, and finally the number 36 itself can divide 36. Now the factors of 48. 1 can divide 48, 2 can divide 48, 3 can divide 48, 4 can divide 48, 6 can divide 48, 8 can divide 48, 12 can divide 48, 16 can divide 8, then 24 can divide 48, and lastly 48 itself can divide 48. Take care not to miss any factors. Now let's select the common factors. 1, 2, 3, 4, 6, 12. Is there any other factors common? No, only this much. So among these factors, 12 is the greatest factor. That is, 12 is the greatest common factor. So our H.C.F will be 12. Now the H.C.F of 42 and 56. Factors of 42. Let's write down the factors of 42. 1 can divide 42, 2 can divide, 3 can divide, 6 can divide, 7 can divide, 14 can divide, 21 can divide, and finally the number 42 itself can divide 42. Okay, the half of 42 is 21. After you get 21, the half of 42, then directly write down the number itself. Now the factors of 56. 1 can divide 56, okay. 2 can divide, 4 can divide, 7 can divide, 8 can divide, it's 56, 14 can divide, 28 can divide, and the number itself can divide. Let's select the common factors. 1, 2, 7, and 14. So here the highest factor is 14. That is, the highest common factor is 14. Therefore, H.C.F, that is, highest common factor, is 14. Question number 5. Find the H.C.F of the following numbers by factorization method. Factorization means expressing the given numbers as the product of prime factors. That is, we'll express the number in the form in the prime factor, and we shall take the common prime factor, we shall multiply them, that is, we'll find the product of the common prime factor, which will be our H.C.F. Let's see. Okay. Find the prime factor of 6. 2 into 3, 6. The prime factor of 9. 3 into 3, 9. So, what is our common prime factor? Our common prime factor is 3. So, our H.C.F will be 3. Here, the prime factor of 10, 2 into 5, 10. The prime factor of 15, 3 into 5, 15. So, 5 is the common prime factor. So, our H.C.F will be 5. Let's see in this question. Okay, find the prime factor of 12. Let's see in row. 2, 6 is 12. 2, 3 is 6. We'll find prime factor in this way. So 2 into 2 into 3. The prime factor of 18. 2 9 is 18. 3 3 is 9. So its prime factor is 2 into 3 into 3. Let's see. What are the common prime factors? 2 and 3. Therefore, H.C.F will be the product of the common prime factor. 2 into 3. That is 6. So 6 is the H.C.F of 12 and 18. Okay. The next question, 21 and 35. We will find their prime factors. 21 can be factorized as 3 into 7. 3 7 is 21. And 35 can be factorized as 5 into 7. 5 7 is 35. 7 is the common prime factor. That is, our H.C.F is 7. Only 7 is the common prime factor. So, we shall take only 7. Let's see here. Let's factorize 28. Let's see in row. 2 14 is 28. 2 7 is 14. That is, 28 can be written as 2 into 2 into 7. Remember that we cannot use any composite number. We should use only the prime numbers. Let's factorize 42. 2 2 is 4. 2 1 is 2. 3 7 is 21. So 42 can be written as 2 into 3 into 7. So the common prime factors are 2 and 7. Therefore, H.C.F will be 2 into 7. That is the product of the common prime factors. So 2 7 is 14. This is our HCF. Okay, the next question. Factorize 45. Let's see in row. 3 1 is 3, 3 5 is 15, 3 5 is 15. That is 45 can be written as 3 into 3 into 5. Now factorize 60. 2 3 is 6, 2 0 is 0, 2 15 is 30, 3 5 is 15. So 2 into 2 into 3 into 5. So these are the prime factors of 60. Let's select the common prime factors 3 and 5. Therefore, HCF will be the product of 3 and 5. 3 5 is 15. So 15 is the HCF of 45 and 60. Okay. Now, factorize 50. 2 25 is 50. 5 5 is 25. So it can be written as 2 into 5 into 5. 75. Factorize 75. 3 2 is 6. 3 5 is 15. 5 5 is 25. So it can be written as 3 into 5 into 5. What are the common prime factors? 5 and another 5. Therefore, HCF will be the product of 5 and another common prime factor. 5 into 5, 25. So this is the HCF of 50 and 75. Number H, 72 and 96. Factorize 72. Let's in row. 2 3 is 6, carry 1, 2 6 is 12, 2 18 is 36, 2 9 is 18, 3 3 is 9. So 72 can be factorized as 2 into 2 into 2 into 3 into 3. Now let's factorize 96. Let's in row. 2 4 is 8, carry 1, 2 8 is 16, 2 2 is 4, 2 4 is 8, 2 12 is 24, 2 6 is 12, 2 3 is 6. 2 into 2 into 2 into 2 into 2 into 3. So what are the common prime factors? 2, 2, 2 and 3. Therefore, HCF will be the product of 2, another 2, another 2 and 3. So multiply them. 2 2 is 4, 4 2 is 8, 8 3 is 24. That is 24 is the HCF of 72 and 96. Now we are given the three numbers and we have to find their HCF. As usually the process is the same, but while selecting the common prime factors, we have to take care that we should select the prime factors, that is the common prime factors of all these three numbers. You are not allowed to take the common prime factors of any two numbers. Let's see. Factorize 30. So 15 is 3 5 is. So it can be written as 2 into 3 into 5. Factorize 45. 3 15 is 3 5 is. So it can be written as 3 into 3 into 5. Factorize 60. 2 30 is 60. 2 15 is 30. 3 5 is 15. 2 into 2 into 3 into 5. As I told you that while selecting the common prime factor, you have to select the common prime factor of all the three numbers. Let's see. 3, 3 and 3. So the number 3 is common between all these three numbers and another common prime factor is 5. Therefore, HCF will be 3 into 5, which is 15. You are not allowed to take this 2 and this 2. Since it's common between 30 and 60, But in 45, there is no any prime factor 2. Similar to question number I, the numbers are 48, 72 and 96. Let's factorize 48. Let's do in row. 2 to the 4, 2 4 the 8, 2 12 the 24, 2 6 the 12, 2 3 the 6. So it can be written as 2 into 2 into 2 into 2 into 3. 72. Let's in row. 2 3 the 6, 2 6 the 12, 2 18 the 36, 2 9 the 18, 3 3 the 9. So 2 into 2 into 2 into 3 into 3. Now 96. Let's factorize 96. 2 4 the 8, 2 8 the 16, 2 2 the 4, 2 4 the 8, 2 12 the 24, 2 6 the 12, 2 3 the 6. 2 into 2 into 2 into 2 into 2 into 3. Take care not to miss any prime factors. Now let's select the common prime factors. 2, 2, again 2, and lastly the common prime factor 3. So our H.C.F is 2 into 2 into again 2 into finally here the common prime factor 3. 2 to the 4, 4 to the 8, 8 3 is the 24. This is the H.C.F. Now the next number 84, 126 and 189. Factorize 84. Let's in row. 2 4 the 8, 2 to the 4, 2 to the 4, 202, 3 7 the 21. So it can be written as 2 into 2 into 3 into 7. Factorize 126. Let's in row. 2 6 the 12, 2 3 the 6, 3 2 the 6, 3 1 the 3, 3 7 the 21. So 2 into 3 into 3 into 7. Now we'll factorize 189. Since we cannot divide with 2, so we will divide with 3. 3 6 the 18, 3 3 the 9. Now again by 2, 3 2 the 6, 3 1 the 3. Again by 3, 3 7 the 21. So it is written as 3 into 3 into 3 into 7. Now the common prime factors are 3 and 7. Only the prime factors 3 and 7 are common. Therefore H.C.F equal to 3 into 7, 3 7 the 21. Now the next numbers are 105, 140 and 245. Let's factorize as usually. Let's in row. We'll divide by 3. 3 3 is 9, 3 5 is 15, 5 7 is 35. So it can be written as 3 into 5 into 7. Factorize 140. We can divide by 2. 2 7 is 14, 2 0 is 0, 2 3 is 6, 2 5 is 10, 5 7 is 35. So 2 into 2 into 5 into 7. Now factorize 245. It is not divisible by 3, so we will do by 5. 5 4 is 20, 5 9 is 45, 7 7 is 49. So we shall write it as 5 into 7 into 7. Let's see the common prime factors 5 and 7. Therefore H.C.F is 5 into 7. 5 into 7, 35. So 35 is the H.C.F of 105, 140 and 245. Question number 6. Find the HCF of the following numbers by division method. Okay, let's recall again. In division method, the smaller number will divide the greater number, and the remainder which comes will again divide the divisor. This process goes on and on until the number which can divide exactly the divisor will be considered as HCF. Let's see this number. 18 is the smaller number. 18 will divide 24. 18 1 the 18, 18 2 the 36. So 18 1 the 18. It will go by 1. 6 will be the remainder. Now the 6 will divide 18. 6 3 the 18. Here the number 6 has divided exactly. Therefore HCF will be the number 6. So 6 is our HCF. Let's see in this number. The smaller number will divide the greater number. 28 1 the 28. Since 28 2 the it would be 56, it will not go by 2. So 28 1 the 28. 15 minus 8, 7. 2 minus 2, 0. Now 7 will divide 28. 7 4 the 28. 7 has divided exactly. Therefore our HCF will be 7. So 7 is the HCF of 28 and 35. Now the next number. As usual, the smaller number will divide the greater number. 42 will divide 70. 42 1 is 42. 42 2 is 84. So we will divide by 1. 42 1 is 42. 10 minus 2, 8. 6 minus 4, 2. 28. Now 28 will divide 42. 28 1 is 28. 28 2 is 56. So by 1. 28 1 is 28. 12 minus 8, 4. 3 minus 2, 1. Now 14 will divide 28. It will go on rolling. 14 2 is 28. So the number 14 has divided exactly. Therefore our HCF will be 14. That is the HCF of 42 and 70 is 14. Let's see in this number. 48 will divide 72. 48 1 is 48. 48 2 is 96. So by 1 we shall divide. 48 1 is 48. The remainder comes 24. Now 24 will divide 48. 24 2 is 48. 24 divided exactly. Therefore HCF will be 24. Next number. 60 and 90. 60 will divide 90. 61 is 60. 62 is 120. So it will go by 1. 61 is 60. The remainder 30. 30 will divide 60. 32 is 60. So our HCF is 30. Now this number. The smaller number will divide the greater number as usual. 72 1 is 72. 72 2 is 144. So by 1. 8 minus 2 6. 10 minus 7, 3. 36 shall divide 72. 36 2 is 72. So our HCF is 36. So 36 is the HCF of 72 and 108. Now we are given the three numbers. In such case, the smallest number shall divide the greater number, and whatever the HCF comes, it shall divide the greatest number at last. And see whether the same number is the HCF of all the three numbers. Let's see. The smaller number is 96. It will divide the greater number 144. 192 shall sit for some time. 96 1 is 96. 14 minus 6, 8. 13 minus 9, 4. The 48 shall divide 96. 48 to the 96. Now we got 48 as the HCF of 96 and 144. Now 48 will divide 192. Now 48 will divide 192. 48 4 the 192. Now we can say that 48 is the HCF of all the three numbers. Therefore, you can write here HCF equal to 48. That 48 is the HCF of 96, 144 and 192. Similar to question number G, here also the smaller number will divide the greater number. The smaller number is 100. It will divide 150. 100 ones are 100. The remainder is 50. 50 shall divide 100. 52 is 100. So 50 is the HCF of 100 and 150. Now let's see whether it is also the HCF of 200. 50 shall divide 200. 54 is 200. Now we can say that 50 is the HCF of all these three numbers. Therefore, HCF is 50. Okay. Now, creative section B. Question number 7a. Find the greatest number that divides 36 and 60 without leaving a remainder. Here, without leaving a remainder, it indicates that the number should divide 36 and 60 exactly. So what could be the number that can divide 36 and 60 exactly? That is, this number should be the perfect divisor of 36 and 60. So let's see in the question. The question says that the number is the greatest number. So whenever the question says greatest, largest, biggest, tallest, then you should find HCF. Let's see again. When the question says greatest, tallest, biggest, largest, the superlative of anything, then we should find out HCF. Do not be confused in it. So let's find out. Find the HCF of 36 and 60. 36 ones are 36. The remainder will come 24. 24 will divide 36. 24 ones are 24. The remainder will come 12. 12 will divide again 24. 12 to the 24. So the greatest number, that is HCF, our HCF is 12 and the 12 is our greatest number. Therefore, the greatest number is 12. Do not be confused in it. The question is asking us the HCF, but in another way. The question says the greatest number and the HCF itself is the greatest number. Question number 7b is similar to question number 7a. Find the greatest number that divides 54 and 90 without leaving a remainder. Only the number has been changed, rest is the same. So whenever it asks the greatest number, we should find the HCF. Let's find the HCF. 54 will divide 90. 54 ones are 54. 36. The 36 will divide 54. 36 ones are 36. 18 is the remainder. 18 will divide 36. 18 to the 36. So our HCF is 18. That is, the HCF is the greatest number. Therefore, the greatest number is 18. Question number 6a. On the occasion of Biswan's birthday, he distributed 24 Snickers and 36 Cadbury's equally to his friends. Find the greatest number of his friends. How many Snickers and Cadbury's did everyone get? Here everyone indicates each of his friends. So, on the occasion of his birthday, Biswan has to give 24 Snickers and 36 Cadbury's to his friends. But he cannot give to all of his friends. So he has to find out the maximum number of friends to whom he can distribute 24 Snickers and 36 Cadbury's. So to find out the greatest number of his friends, what should we do? As we had done in the previous question, to find the greatest number, we should always find H.C.F. That is, we should find the H.C.F of 24 and 36, which will give us the greatest number of his friends. So let's do it. 24 will divide 36. 24 1 is 24. The remainder 12. 12 will divide 24. 12 2 is 24. So our H.C.F is 12. That is the maximum number of his friends. The greatest number of his friends is 12. So let's write the greatest number of his friends is 12. So he can give 24 Snickers and 36 Cadbury's to the maximum number of friends, which is 12. That is, he cannot give to more than 12 friends. If he give his Cadbury's and Snickers to more than 12 friends, then he might not distribute them equally to all of his friends. Now we have to find out that how many Snickers and Cadbury's did each of his friends get. Now, since there are 12 friends, so this 12 will divide 24 Snickers. 12 2 is 24. So each of his friends got 2 Snickers. Now 12 will divide 36. 12 3 is 36. Each of his friends got 3 Cadbury's. So let's write the conclusion. Therefore, each of his friends got 2 Snickers and 3 Cadbury's. The next question is similar to 6a. Find the maximum number of children to whom 30 sweaters and 45 trousers can be equally divided. Also, how many sweaters and trousers will each get? Here the question is asking the maximum number of children. And when the question asks us the maximum or the biggest, we should find H.C.F. That is, we'll find the H.C.F of 30 and 45. Okay. 30 will divide 45. 31 is 30. 15 remainder. 15 will divide 30. 15 2 is 30. Our H.C.F is 15. That is, the maximum number of children is 15. Therefore, the maximum number of children is 15. Now, among the 15 students, we have to distribute 30 sweaters and 45 trousers. The question is asking how many sweaters and trousers will each children get. Let's find out. Now, 15, which is our maximum number of children, will divide 30 sweaters. 15 2 is 30. That is, each children will get 2 sweaters. Now again, 15 will divide 45 trousers. 15 3 is 45. Each children will get 3 trousers. Let's write a conclusion. Each children would get 2 sweaters and 3 trousers. The next question. A container can hold 40 liters of milk and another container can hold 60 liters of milk. What is the maximum capacity of a jar that can be used to measure the milk of both containers? Let's understand by the figure. There are 2 containers. One container containing 40 liters of milk and another container is there containing 60 liters of milk. Now I need the capacity of a jar. Okay, let's say this is a jar. And what is the capacity of this jar that can empty both containers? This jar should empty this, taking out the equal amount of milk. That is, if this jar takes out the 20 liter, then next time it should take out the same amount, 20 liter, next time also 20 liter. In this way, this jar should take out the same amount which it had taken out from this jar. That is, this jar should be the common of 40 liter and 60 liter. So what should we find out? We should find out the maximum capacity of the jar. The maximum capacity of the jar that can empty both containers. The question is saying that can be used to measure the milk of both containers. The same thing, it should be able to empty both containers, taking out the equal amount of milk. So what should we find out? The same thing. The question says the maximum capacity. So when the question says the maximum or biggest, we should find out the H.C.F. So find the H.C.F of 40 liter and 60 liter. So 40 will divide 60. 41 is 40. 20 remainder. 20 will divide 40. 22 is 40. So the maximum capacity of the jar is 20 liter. The maximum capacity of the jar is 20 liter. Let's see in the figure again. This is 40 liter, the container containing 40 liter of milk and the container containing 60 liter of milk. So there is a jar which is of 20 liter and this 20 liter can empty this jar 2 times. So this 20 liter jar, when it empties this, then it has to take out 20 liter. In 2 times it can empty this jar and in 3 times it can empty this jar containing 60 liter. So the maximum capacity of the jar is 20 liter. Okay, the next question. A rectangular courtyard of a house is 18 meter long and 15 meter broad. It has to be paved with the square stone of same size. What would be the length of the greatest stone? Let's understand by figure. There is a courtyard. Courtyard means the land where the house is built. That is the area of the land, the surrounding of the land. And this land, this courtyard, has to be paved with square shaped stone. And I need the stone, the square shaped stone, and this should be of the greatest size. That is, I need the greatest length and breadth of the stone. So the question is asking, what is the greatest size stone which I need to pave this courtyard? So when the question asks the greatest, what should we find? We should always find the H.C.F. So let's find the H.C.F of 15 meter and 18 meter. 15 minus 15, remainder 3. Now 3 shall divide 15. 3 5s are 15. So what is the length of the greatest stone? The length of the greatest stone is 3 meter. the greatest length of the stone is 3 meters. Let's see in the figure. The question says this courtyard is 15 meter broad and 18 meter long. So if I pave it with 3 meter length and breadth stone, then will the stone occupy this area? Yes, 3 meter, 3 meter, again 3 meter, 3 meter, 3 meter and 3 meter. Let's see. 3 meter, 6, 9, 12, 15 and 18. So the length is 18 meter and the 3 meter length, it occupied the length. And again, the breadth is also 3 meter. So 3 meter, 3 meter, 3 meter, 3 meter and 3 meter. Let's see, this 15 meter breadth is also occupied by the same stone having the breadth 3 meter. So in this way, the size of the greatest stone is 3 meter. Well, we have completed the exercise on H.C.F. I shall be back soon with my next video on LCM. Till then, stay safe, be at home, take care, bye bye.